Hello everyone, and we are back again talking about some more of the features of the Kubro EXA8 platform that would appeal to developers or anybody who wants to roll their own custom solutions. In a previous video, we looked at what the EXA8 actually is, the software implementation that already exists from Kubro, the hardware and the software powering the EXA8, which is an ARM 64-bit processor and a full install of Ubuntu 16.04, and then I also introduced the Elevate the EXA8 Challenge, a contest that is currently being run by Kubro, where developers or anybody else who's interested get to create their own applications or use cases for the device and submit those for a chance to actually develop on the device and win a monetary prize. In this video, we are going to talk about the interfaces that the EXA8 has and how we can work with those. So the first interface that we'll talk about is probably going to be the most important one simply because it will be your rescue interface if the management configuration goes awry or anything else stops working the way it ought to. That's the console interface. So this is on the left-hand side of the front face of the device, and it sits right above the management port that we will talk about next. You can access this with a standard rollover cable that we're all familiar with, serial on one side, RJ45 on the other, and likely you'll be using that with a USB to serial adapter these days. But this settings for this console port are simply a 115,200 baud, 8 data bits, 1 stop bit, no parity, no flow control. And this allows us to get root access to the device so that we can maybe fix some configuration errors that we might have introduced while we were working on it, or just so we can work with this if we don't know the IP address or something to that effect. So next, we will talk about that management interface. Now the management interface sits directly below the console interface on the front face of the device. And if I issue an IPA command here, this is the interface designated by ENP5S0F4 on this. We can see the management IP that I have assigned to it right now. Now you can use tools like IP and ifconfig to change the management IP address of this port. I would recommend that not because it does. I would not recommend that, and it's not because it doesn't work, but rather it's because some other aspects of the configuration don't update from there and they don't report the management IP address correctly. So at this point in time, we would want to generally change the management IP either by using the web interface or by using the built-in EX8 CLI command line utility that is built for this purpose. So if you issue EXA8-CLI at the command line, then you will open up this utility, and from here you can do the typical question mark to get your options, and we can do things like show the current management IP address, and then if we enter the configure mode, we can go ahead and change that management IP address from here. Now, of course, if we're developing our own custom solution, we're not going to be using this method to do things like this. So all of this has a REST API call that we can issue as well inside of the applications that we build. And we'll look at the REST API stuff in the next video. But just to let you know about that. So let's talk about the XV interface next. And the XV interface is probably the most unique interface that we have available here because this is effectively our capture interface. This is our virtual interface that we can forward traffic to. So whereas all of these other interfaces are physical interfaces, the XV interface is our virtual interface, and any traffic that is directed towards this interface, we can monitor or capture. In the Kubro software, this is where we capture our live capture and rolling capture stuff from. This is also where the built-in NTOP utility is going to pull its information from. And we can do things like TCP dump or tshark on this to capture from the command line. So I put this in verbose mode and point that at the XV interface. Actually, first let me issue ifconfig, and we can see that there is traffic traversing this interface right now. I have it coming in 2 of our 1 gig copper ports, and it's being directed towards the XV interface. And now let's try that TCP dump. And we can see we have all of this traffic that we can capture using any capture utility that we feel appropriate. Something else that I did was I went ahead and grabbed iftop from the repos. So we can do something like iftop, and then we can point that at the virtual interface, and we can start to look at who all of our top talkers are and our, our IP conversation pairs with a utility like this. Again, no end to the possibilities for what we can use, but this interface is our window into uh, monitoring the traffic that's coming into the device using these command line utilities. So in that respect, it's probably the one that you're going to be relying on the most whenever you build your own custom applications. That would be my guess anyway. Now next we have our physical interfaces. So we have our two 1 in 10 gig copper, or I'm sorry, 1 in 10 gig SFP plus interfaces, and we have our 8 copper interfaces. Now a note about these, the copper interfaces feature a built-in bypass functionality. So from top to bottom, in each of these sections, these will maintain the live link even if power is lost. The relay will flip over and it'll maintain the live traffic flow even if the EXA8 has no power or is turned off. So from G1 to G2, from G3 to G4, from G5 to G6, and from G7 to G8, these are fail-safe interfaces. Now you can forward traffic from G1 to G4 or from G6 to G7, and that'll work just fine. You just won't have that built-in fault protection like you would if traffic was being forwarded directly from G1 to G2, G3 to G4, and so on and so forth. These also can be used as strictly inputs, so all of these can function as independent inputs if you wanted to feed up to 8 traffic feeds into this device. And the X1 and X2 interfaces are 1 in 10 gig SFP plus cages. Of course, we can aggregate traffic from our copper interfaces to these, or we can use these as outputs. We can actually use these as inputs as well if we so desire. But again, these are not fail-safe. They're powered interfaces, so no fault protection there. So from X1 to X2 and vice versa, there's no fault protection, but you can aggregate to these interfaces and you have that 10 gig functionality in here. Now the way that we would interact with these, again, with the software that's already built by Kubro, we would do all of this through the web UI, or again, we would do all of this through that EXA8-CLI command line utility. So primarily, for our purposes in the discussion of this video, we are again going to be interacting with those interfaces through the REST APIs. So we'll discuss that more in the next video. Now some of the other interfaces that we have here, what we have left over is we have our USB interfaces and our micro SD card slot. So these function just as you would expect in a Linux system. So I can go ahead and plug a USB thumb drive right into my USB port there, and then I could just mount that right to the interface. So go into CD mount, I'll go ahead and create a mount point for that and just call it USB drive. And then let's take a look at what that is. So it looks like that pops up as SDB1 right here at the bottom. So quite simply mount /dev/SDB1 to USB drive. And right there we go. Nothing surprising about this, nothing shocking, but a capability that we have, an easy way to get things onto and off of the device, a way to expand storage. I would not recommend trying to capture to the USB interfaces. Your performance is going to be severely degraded over the built-in storage, but this is a possibility. We can use the micro SD card slot in much the same fashion, so plugging one of those in. I'm going to go ahead and unmount this first because I'm blocking the SD card slot with my USB drive. So again, there shouldn't be anything too shocking about this. Right here we can see that my SD card is mounted as this long mess of whatever. Yeah, it's so hard just to find paste. And there we go. Also, we can plug things like Bluetooth modules or Wi-Fi adapters into here. So if I throw a Wi-Fi adapter into my USB, then we can see that that is recognized. This one has a Realtek chipset, and then you can go ahead and you can compile the drivers if necessary, load the kernel modules, whatever you need to do to use things like your Bluetooth devices, your satellite modems, your LTE modems, your Wi-Fi devices. You can use those to actually manage the device as well once you get those working inside the Linux OS. So that covers pretty much all of our interfaces. I mean, save from the back where the power cord plugs in. I can't think of any other interfaces that we have to work with on this device. So in the next video, we will dive into the REST APIs that are provided to hook into some of those things like aggregation, tapping sessions, and all of that good stuff. So until then, thanks for watching and take care.